This is Miss Humbert here, and today we're going to be reviewing Unit 7. So we're going to be talking about probability. So let's take a look, and I kind of just have a whole bunch of different probability word problems put together so we can kind of figure out when we need to use what method. So taking a look at this first one, it says Farmington High School soccer team has orange, white, and black jerseys. The team uses orange or black pants. So those are two options. So there's two options for our pants. Black or white shoes. So there's two options for our shoes. And so it says to use the fundamental counting principle to figure out how many uniforms they wear. It also says they have orange, white, or black jerseys, which is three options for the colors. So really all we have to do is multiply all of our different options together. So 2 times 2 times 3 is going to give us 12 ways or 12 different uniforms that the team could be wearing. So let's go ahead and let's take a look at number 2. Mackenzie is setting up a display of the 10 most popular video games from the previous week. So she's placing the games 12 side by side on a shelf. And so how many different ways can she arrange them? So she has 10 videos. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when she starts off lining up the videos, she has 10 to choose from. And then when she chooses one, she has 9, and then 8, and then 7, and she's going to keep going down by 1 until she has the entire shelf filled with videos. So if you guys remember, this is also the same as 10 factorial. So when you multiply that out in your calculator, you end up getting 3,628,800 different ways that she could arrange those DVDs on the shelf. Okay? Next, let's take a look at number 3. It says there are 10 finalists in a figure skating competition. How many different ways can gold, silver, and bronze medals be awarded? So here I need to ask myself if order matters. And to me, gold is very different than bronze, so the order does matter. So we have 12 finalists in the figure skating competition, and we're picking 3. We want to use a permutation. So up top, we have 10 factorial. And then on the bottom, we're going to have 10 minus 3 factorial. So notice that the formula for permutations, you're taking the difference of the two. And if you want that for your cheat sheet, this is what it's going to look like. Oops. I don't want 10 factorial, I want n factorial. And there's the formula for permutation. So then here I get 10 factorial, and that's going to be divided by 10 minus 3 factorial, which is 7 factorial. So everything from 7 on down in that factorial is taken care of, which means up top I have 10 times 9 times 8. And I multiply that out, and I get 720 different ways that I can arrange that. So that is your final answer for number 3. Next, let's take a look at number 4. And how many ways can the letters in the word geometry be arranged? So first thing I want to do is count how many letters I have. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 letters in the word geometry. So up top I'm going to do 8 factorial. Then I need to divide by any letters that are being repeated. So I notice that E is being repeated twice. So I'm going to divide by 2 factorial. So 8 factorial divided by 2 factorial. So everything from 2 on down is going to be taken care of. So that means I need to write 8 factorial all the way down to 3. So then in my calculator, I'm going to do 8 times 7 times 6 times 5 times 4 times 3. And when you multiply that out, you get 20,160 different ways that you can arrange those letters. Okay, let's take a look at number 5. So it says a group of 7 seniors, 5 juniors, and 4 sophomores have volunteered to be peer tutors. Mr. Picard chose 12 students out of that group. How many ways can 12 students be chosen? Well, does it matter the order in which he chooses the students? No, it just matters which students he chooses. So if you add 7 plus 5 plus 4, you end up getting that there are 16 total students, and we're choosing 12 of them. So then up top I have 16 factorial, and then on the bottom I need to write the difference of the two. So 16 minus 12 factorial, but then for combinations you need to have that extra factorial on the bottom. So the formula for combinations is n choose r is equal to 16 factorial divided by 16, I'm doing the numbers again. Let's do this as a formula. Okay, so then it should be, sorry about that, n factorial divided by n minus r factorial and then times r factorial. not n factorial. That looks like an n. R factorial. There. Okay, so let's go ahead and finish solving this out. So what I have is 16 factorial divided by 4 factorial, 12 factorial. So 12 is the bigger factorial. So everything from 12 on down is going to be taken care of. So left up top, I have 16 times 15 times 14 times 13, and I'm going to stop when I get to 12. And then I have 4 times 3 times 2 times 1. So then you're going to multiply across the top. When you multiply across the top, you end up getting 43,680. When you multiply across the bottom, you end up getting 24. And then you can go ahead and divide those out, and you get 1,820, and then your label is ways. So that's the number of different ways that you could do this. Let's take a look at number 6. You have a bag with 3 red marbles, 2 green marbles, and 5 blue marbles. What is the probability of grabbing a blue marble? So we have 3 plus 2 plus 5. So there's 10 total marbles. So when you're doing probability, it's always your success over your total. Or a success is getting a blue. So that's 5 out of our total, which is 10. Divide those out and you get 0.5. So there's a 50% chance of you getting a blue marble. So let's take a look at some of these probabilities. Remember that and means you need to multiply. That might be a good thing to have on your cheat sheet. That and means multiply. So 3 cards are drawn from a standard deck without replacement, and we need to find the probability of drawing a heart, another heart, and a spade in that order. So if we're not replacing it, that makes this a dependent event because our total is going down. So starting off, we have 52 cards, and a heart is one of our suits. So there's 13 of them. I might suggest you pull out your probability review note sheet and just jot down a couple things about cards on that review or on your cheat sheet. So 13 out of the 52 are hearts. Well, I'm going to take that heart and set it aside, which means I only have 51 cards left, and I also only have 12 hearts when I set it aside. So I'm going to take that card and set it aside. So now I only have 50. However, I know the first 2 that I've drawn are hearts, which means my third one is a spade, and I haven't drawn any spades yet, so we still have 13 spades left in the deck. So we have 13 times 12 times 13 is 2,028, divided by 52 times 51 times 50, which is 132,600. So then to get your decimal, you're going to go ahead and divide that out. I usually should suggest doing to 2 decimal points. So I have 0.015, or to 3 decimal points, sorry. So when you're rounding to 3 decimal points, make sure you look at the 4th decimal point. If it's 5 or greater, remember you need to round up. Let's take a look at number 8. So for number 8, there are 3 miniature chocolate bars and 5 peanut butter cups in a candy dish. Liz chooses 2 of them at random to eat. What is the probability that she chooses 2 miniature chocolate bars? Again, this is dependent. If we take out a miniature chocolate bar, we're going to eat it. We're not going to put it in there. So we have 3 plus 5. So there's 8 total candies in the dish. And 3 of them are miniature chocolate bars. So she takes one out and she eats it. That means there's only 7 left in the dish, and only 2 of them are miniature chocolate bars. So now we can multiply across the top. 3 times 2 is 6. 8 times 7 is 56. 6 divided by 56 is 0.107. I might suggest typing that in your calculator to make sure you know how to do it, as well as making sure you know that you're rounding correctly. So let's take a look at number 9, just as a reminder that OR means you need to add the probabilities. Again, another good thing to remember. One teacher must be chosen to supervise a senior class fundraiser. There are 12 math teachers, 9 language art teachers, 8 social studies teachers, and 10 science teachers. If a teacher is chosen at random, what is the probability that teacher is either language arts or social studies? So we need to add. So what we need to do is first figure out the probability that it's a language arts teacher. Well, we have 12 plus 9 plus 8 plus 10. So that gives us a total of 39 teachers when you add all of those up. And 9 of them are language arts teachers. Now I'm going to find the probability of getting a social studies teacher. Well, that is going to be 8 out of the 39. So then I need to ask myself, is someone going to be a language arts and a social studies teacher? Probably not. So I don't need to subtract anything off. So I have 9 plus 8 up top, which is going to give me 17. And then that's going to be divided by 39. So then to get my fraction, I'm going to go ahead and divide those out. And I end up getting 0.436. So that one had some tricky rounding. The 4th number was an 8, so I rounded the 5 to a 6. Last but not least, let's take a look at number 10. There are 2,400 subscribers to an internet service provider, 1,200 own HP, 500 own Dell, and 100 own both. What is the probability that a person owns an HP or a Dell? Okay, so we already know that there's people who own both. So that makes this an inclusive event. There's stuff that we're going to have to subtract off. So first thing I'm going to do is calculate the probability that they own an HP. So there's 1,200 people out of the 24,000 subscribers that own an HP. Then there are 500 that own a Dell. So we do that. And now we need to subtract the probability of those people owning both, because those people owning both are being counted there and there. So remember, when you're adding fractions, you always keep the denominator the same and only add the numerator. So there are 100 people that own both. So then going across the top, we're going to add, and subtract. So I end up getting 1,600 divided by 2,400. Again, my bottom staying the same. And when you divide that out, you end up getting 0.67, or you could do 0.667 as well. So that concludes your video. There is no Schoology quiz for this, and thanks for listening.